Okay, just making sure. Hey, everybody. Letting everybody filter in. Hello, hello. Looks like participants are joining, so I'll give it 30 seconds and then we'll go ahead and kick off. All right. Hello from Hungary and Denmark. Okay. Um, we'll go ahead and get started. I hope everybody's enjoyed the event so far. We'll start with a quick introduction. My name is Jad El Zain. I've been VMware for about almost 16 years. Next month will be 16 years. And I've done all kinds of different things, but most recently, I've been focused on modern applications on the VCF stack. And what I mean by focused on is, having these types of conversations, helping with the path forward in our strategy, and speaking with customers and partners alike about what it means to have a modern application on VCF, right? There's a lot of benefits. We're going to focus on a few of them. And, please do ask questions with me, who I don't think can speak or can unmute their microphones, are two of my colleagues, Miles and Audrey, and they are standing by to answer questions. So if you do have questions that we can answer, please do go ahead and do that in the chat. And otherwise we'll go ahead and get started. Looks like we've got a good amount of people on, so let's get going. Okay, so today we're going to talk about primarily what conformant Kubernetes means in terms of VCF. So the way I wanted to structure this presentation is essentially positioning or helping you all understand when we are out there, we VMware are out there talking about what a conformant platform or conformant Kubernetes runtime or Kubernetes distribution and so on. What that means in terms of VCF is something that we're doing more and more. And I think there is some opportunity to help our customers better understand our positioning as far as running Kubernetes. But to skip to the very end, the idea here is that VCF and our Kubernetes services are designed to run your Kubernetes workloads, period. So I'm going to break that down, talk about what we've done to get here, what it means to be conformant, and then we'll talk a little bit about what a resilient Kubernetes platform is, and how we monitor performance and so on. Okay. And if there's anything pressing, again, use the chat, and Miles and Audrey will be very helpful, I'm sure. Okay, so also Audrey and Miles will keep me on time, which I'm horrible at. So here's a quick glance of the agenda. And by now, I'm going to assume that everybody who's on this call has an understanding of where we are in terms of VCF. So VCF 9, VCF 9.0.1 specifically, what has been the latest platform release. So I'm not going to spend a whole lot of time on VCF itself, because we need to save that time on the modern apps conversation. Okay, so let's jump into what our customers and enterprises and organizations in general are asking for / demanding in terms of modern apps. Now, I do want to take this a second to define what a modern app is. A modern app is any app. It's not that, like, if you're running modern applications, or if you're running an application in a production environment, and your business or your customers or whoever it might be rely on that application, it is in this bubble of modern apps. It exists today in whichever form it may exist. And we want to look at all of those applications and being able to provide the performance, the security, the compliance, the scalability, and all that for all of those applications. Now, modern apps traditionally means modern cloud native, right? Microservices and so on. But in this world, presumably, most of you are coming from a monolith OS-based, VM-based application environment and have seen the transition into microservices. So we have to start treating all of these things together, because even if it's not modern in the traditional sense, it is still a business critical application and it needs to benefit from these technologies and capabilities. All right. So with that behind us, some of the things that our customers are demanding, probably you all are demanding. First of all, consistency. Driving consistency is key to reducing complexity. It's key to eliminating threats, or at least reducing threats. It's a key for efficiency. And consistency of virtual machines in Kubernetes means as I spin up these modern app services or these modern capabilities, or even if it's just a web tier of my modern application, it needs to be done in a very consistent way. We need to get past the days where I have a process for application A and a whole separate process for application stack B, and yet a whole other process for stack C. And by processes, I mean, how do I secure it? How do I load balance it? How do I report it or log it or flow it? How do I get the observability? How do I know who has access and who can control it and how to lifecycle it and all those things? As I have to do what we used to call swivel chair management. It's adding additional layers of complexity and compliance issues that I probably would be better off avoiding. So consistency is more than just like, hey, just use these tools. It actually brings processes and methodologies together. So consistent is up top because it actually impacts everything else. A unified platform, lots of rationale behind this. Why this also ties into consistency and cost, right? Why should I stand up separate platforms to do separate things? Why not leverage a world-class virtualization platform to run my business critical Kubernetes infrastructure, right? That is exactly what it's there for. I want common experience, common functionality. So as I leverage these modern technologies like vSAN ESA and NSX and these capabilities that VCF provides, let me use those across the board, right? I should not have to determine or decide which app gets to use which technology. They all should come together. Manage it, lifecycle it. I need to be able to do all of this also consistently. And then, of course, we have to do more with less. That's a constant theme. How do we provide these services in a way that are available for self-service and support my production engineers, right? My PEs or platform engineers, my DevOps teams, and so on. The last couple here are really about the life cycle and the operation of Kubernetes. And this is something that is typically where some of the public cloud services really took off back in the day. And it's scalability, right? With public cloud, we think we have this infinite scalability. With infinite scalability comes infinite bills and costs. And so when we want to build applications, we want to build them to be as efficient as possible and scale and be elastic when necessary. And this is not unique to the public cloud, right? With VCF in the private cloud, we can certainly build on top of this, the virtualization platform that is vSphere, and provide the scalability to Kubernetes in the same exact way we've provided it for our virtual machines and other sets of infrastructure. For all intents and purposes, it is a cloud. And to be a cloud, it has to be scalable and it has to be elastic, right? So customers are making these requests. Right? Also, keeping up with Kubernetes, and this is going to be something that we spend a whole lot more time on. So hopefully you could agree. This is probably a good summary list, not an extensive list, but that's where we are. So let's talk about how we got here. A lot of my peers on the call and customers and folks, we've been talking about Kubernetes for 10 years now, right? It was going to change everything. Well, Docker was going to change everything. We needed it to fit with our traditional processes. And if you remember, if you were in development for a while, waterfall was the way to go, right? Everything was done with purpose, and it was in a line, right? So I would define the requirements up front, and then software was built and tested, and it was sequentially phased out, right? That didn't really keep up with the demand, right? And it still has its place, but it didn't keep up with the demand. So agility or agile processes or methodologies were introduced. And this is where a lot of automation and CI/CD processes came into place, right? So DevOps took this model, took agility into account, and it essentially helped us break down silos between development teams and the operations teams. So continuous delivery, continuous integration, lots of automation, and we started seeing the efficiencies of development pick up. However, with the big shift into microservices, the need for elasticity, the need for massive amounts of scale, we needed to take it a little step further. And this is the resilience layer of Kubernetes and containers and containerization fits. And this took us to more of a GitOps model, right? Now, with all of this said and done, and obviously this is where the majority of the Kubernetes conversation happens in cloud native, microservices and so on. Now, with all of this said and done, our friend, the monster VM here, is still alive and well. So the idea is, how do I take advantage of what app modernization is and take advantage of the tools and services, but also meet the demand and the requirements of delivering cloud native applications, but also be able to consider the needs of my more traditional monoliths, right? Not VMs themselves aren't what I'm talking about. I'm talking about the actual monolith applications that have existed in your data centers for decades, essentially. For those of you who have been around, you probably get the monster VM joke. If not, I'm sorry, I could explain it later. So these virtual machines, right, your traditional OS-based workloads, Lin, so on, running in your data centers, those aren't going away. If they exist today, Kubernetes has been out for 10 years, containerization and all these different processes to modernize applications have been going on for quite some time. If those VMs are still running in production today, you need to understand how the rest of this, the cloud native world, your modernization tasks and future integrate with that, right? 10 years ago, we were talking about how Kubernetes was going to replace everything. But the reality is that's just not the way it worked. It's not the way it panned out. And it's not going to pan out that way anytime soon. Sure, we can still strive for it. But what's happening is that these big monster VMs and these monolith applications are actually getting split up a little bit. But you still have this pretty large persistent backend component while my web front end moves to a microservice. That was like the easy path into starting to adopt microservices. Now, I'm saying that a little bit of a negative tone there, but there are certainly some customers who have gone all in, who have made massive investments and accelerated the path to modernization and are well on their way to being exclusively modern apps, the way it's defined. So sure, but chances are you're somewhere in between, okay? So The idea here is build a platform. We are allegedly here. Build a platform or provide a platform that can support all workloads, all methodologies, but strongly focusing today on that GitOps, microservices, Kubernetes, and so on. And that will take us into the rest of this conversation. Okay, so here's what we are here to do, right? Here's what VCF is striving to do. Simplify. Do you remember the P2V conversations? Those conversations of moving physical to virtual lasted a couple of years, but as things picked up, the idea was consolidation and efficiency and simplifying management of all my workloads instead of these rack and stack physical boxes, right? Secure and harden these environments for all workloads, not just your microservices, not just your VMs, for all workloads. And then reduce friction in deploying your next generation of workloads. Now, you can't have the Kubernetes conversation without talking about AI and vice versa. A lot of AI is the quintessential modern workload, and so you'll see that in there at all. Right. Now, all of this is designed to simplify the experience for all of us. Miles just reminded me I have 30 minutes. I'm telling you, I talk too much, so I'm going to start hurrying up. So Cloud Foundation 9, and by now you've heard a whole lot more about this, but this is where VMware has doubled, if not quadrupled down on running these modern workloads, even from the previous version, 5.2, and the individual components of 5.2 to where we are today. I mean, it's a significant advancement and a significant focus, both from an engineering perspective and an investment for VMware to make this the single private cloud. And so we break it up typically in these three categories: modernizing your infrastructure, modernizing your applications, and modernizing your security. Because without without security modernization, your apps and infra are SOL. So we do focus heavily on how to do all of this in a compliant, secure way. Now, as we start getting deeper and deeper into the platform itself, one of the ongoing themes here is the conformant Kubernetes. And what that means, and we'll get into a little more detail, what that means is a Kubernetes distribution that is expected to work as any conformant Kubernetes distribution or service works. So that means as VMware built out this portfolio and these capabilities, we wanted to first plug it into all the benefits of VCF, so compute, storage, networking. In other words, vSphere, vSAN, NSX, all of the operational capabilities of VCF Ops, automation from VCF Automation. And then as we're bringing these capabilities in, the individual Kubernetes capability assets in, we also need to support all of their native services, right? We want to be able to support the entire CNCF third-party library. We want to obviously be able to support your modern applications. And so this is these are the, I don't want to say remnants, but this is the culmination of some of the Tanzu assets that came back over to VCF back in April to make this platform whole, right? So again, you've probably seen some of this already. And this all kind of comes out of what's called the supervisor, which is the control plane of our Kubernetes story, right? So the supervisor delivers a single declarative API so that when you're interacting with this environment, regardless of what kind of workload it is, we're doing it in a way that is very consistent with Kubernetes interactions or Kubernetes methods, right? So it's that declarative API. I'm able to consume, manage, operate, interact, or interface with these services all through this one common API thanks to this supervisor. And the supervisor provides that consistent consumption right? A consistent UI or consistent experience. And it abstracts the underlying hypervisor and the underlying physical hardware. And at this stage, when you're interacting with Kubernetes, what's underlying should already have been abstracted, just like it would be in AKS or EKS or GKE and so on, right? When you interact with the cloud and using Kubernetes and cloud services, you don't interact with the physical hardware. And so vSphere provides that at the virtualization layer, and then Supervisor further abstracts even vSphere and the foundational components of the cloud to give you this declarative API and this consistent consumption model. Okay, and so in terms of security, also we provide on top of the supervisor, we provide isolation across workloads and across vSphere namespaces to give us isolation from application to application. And this construct actually now impacts all applications or all workloads running in the VCF cloud. So I could have virtual machine workloads running in the VM service. I can have Kubernetes workloads running on VKS. And all of these provide level of different, the namespaces provide different levels of isolation, right? This includes network separation and so on that we can do down in the stack. So now, just to try to get back on time. So conformant Kubernetes, let's talk about what it actually means to be conformant. And to be honest, this is not some publicly adopted, well-known 4 pillars of being conformant, but it is essentially there, right? So API consistency, by the way, this is if you were to ask CNCF, how do I make my Kubernetes distro conformant? This is where we're at. That's what I meant to say. API consistency, I'm going to hit that API and I have to have pretty consistent and expected outcomes regardless of the provider of those services or that dial tone. Interoperability, so seamless integration with the tools I use in any other conformant Kubernetes infrastructure. Which means I need to be able to, use the same exact tools in managing and operating or deploying or provisioning or whatever it might be, my AKS or EKS infrastructure or OpenShift Kubernetes runtimes as I would with my VCF. Cool. And portability runs along those lines as well. And then community trust. So being conformant means that you are building to the community, to CNCF specifically, and you are you've built a platform that is based on open standards, right? There are a few solutions out there, not mainstream, but a few solutions out there that either are or have started as like a fork of Kubernetes and then has some proprietary components to it. Not a lot, but that does exist, and that would be an example of a non-conformant Kubernetes cluster. The takeaway here is VKS is a conformant cluster based on our CNCF certification. So VKS itself, this is the service that allows us to deploy upstream conformant Kubernetes clusters on demand. VCF makes it on demand. So VKS, it's designed to take advantage of the entire VCF stack, specifically on the compute, storage, and networking stack, whereas my management and automation operations happens basically above it. And it is integrated into VCF. So anybody who's had previous experience with VKS, previously called TKGS, there was different levels of interaction required to get it up and running. But as we get into VCF 9 and with VKS being the new name, VMware Kubernetes Service, more and more of that is just expected to be there. That dial tone is just expected to be there, right? So with VCF 9 and moving forward, as I build out workload domains, VKS is essentially a core part of doing that. And you're going to see that happen more and more, and that integration being more and more seamless as we get feedback from our customers and continue to innovate and build out this platform, right? So VKS also takes advantage of all the underlying storage and network services, the tenancy provided by automation, the operational aspects of managing a Kubernetes infrastructure, and so on. And then when we talk about VKS clusters, these are essentially, I'm going to build this out for time's sake. These are essentially deployed in the namespaces, in the user namespace or a vSphere namespace, and our resources, VMs, Kubernetes, the Kubernetes itself all runs inside of this namespace, and then we have the Kubernetes clusters that are available and consumed just like you would any other Kubernetes cluster, right? All of this runs automatically. You configure some of the basic requirements in the YAML, and the rest happens automagically, right? There's a bunch of different UI interfaces, and that's done on purpose. So the Kubernetes service VKS is available to your traditional VI admin. This is the person that interacts largely with vCenter, but more and more often, well, of course, the CLI and our CLI commands and commandlets, but more and more using VCF automation to build and manage VCF clusters. One example of that is what was recently added in VCF 9.01, which is VKS cluster management. Now, this is an evolution of a previous product that's now embedded or essentially rebuilt inside of our VCF automation to allow us to have a consolidated view of all of our clusters. So it gives us management, it gives us life cycle. We can see this universal view of health, versioning information, and so on. We also get centralized place to do our upgrades. So to be conformant, again, we are tracking and continuing to follow Kubernetes releases. And so as a release is made available and VMware goes out and provides that release, we need a nice, seamless, automated way to upgrade those Kubernetes versions across our environment. And this is essentially what allows us to do that. But other pieces of VKS cluster management include the ability to provide templates and policies that that set expectations or set policies for how these clusters are managed, who can access them, and so on and so forth. All right, this is all built into VCFA now. It's not a future. This exists today. And then as those releases are available, the actual releases are published in a content library that is available to your VCF instance. And then we support both Ubuntu and Photon built in, and they follow the releases as they come available. So this becomes available. They're consumed as an image directly from the content library, and then you can spin them out for your VKS clusters. I'm already short on time. And recently announced support for Kubernetes 1.34. Now, this comes inside of the VKS 3.5 package. Don't let that confuse you. VKS is versioned separately than Kubernetes, which makes perfect sense. VKS is part of the platform. Kubernetes is globally versioned the same exact way. So one of the things that I want to take away from here is the ability or is VMware's commitment to supporting releases, right? And in fact, we began supporting and rolling out 1.34 62 days, something like that, after its initial release into our platform to support rapid adoption of these capabilities and rapid adoption of the underlying capabilities that are developed or delivered with 1.34. Now, 62 days might seem like a lot, but it's actually a pretty rapid validation and rolling out from a platform perspective, because some providers will take months and months to do it. And the other big takeaway here is the recently announced support of 24 months from VMware. So non-additional or standard support at no additional cost for 24 months. And that, if you live in this world today, you know that that could be pretty significant. And so that is, again, part of our commitment to help our customers adopt, but also maintain their Kubernetes environments. I think 24 months is industry leading. Right, and if we talk about resiliency, one of the things I mentioned earlier is being able to look at our published versions and using VKS Manager to spin things out and update your actual Kubernetes clusters. But also, the supervisor control plane itself gets maintained and managed independently of that. So the supervisor control plane used to be tied to vCenter. And just before the release of VCF 9, I believe it was vSphere 8.0 update 2 or 3, we actually divorced the two so that customers can get on the latest and greatest control plane, therefore getting on the latest and greatest Kubernetes, without having to upgrade their entire cloud infrastructure. That seemed pretty important to do. And so now with VCF 9, that's even more streamlined, and it's just baked into our fleet management and lifecycle management of the platform. So pretty great things happening there. And if you were paying attention, speaking of resiliency, if you're paying attention of VMware Explorer this past Vegas, we did make an announcement of canonical Ubuntu and VCF for delivering chiseled containers through the platform. And there's a lot of really good reason to do this. Canonical being one of the top or the top cloud OS in the market, has deep experience, and this is essentially us partnering the world-class platform that is vSphere with a world-class OS to deliver Linux and the underlying Kubernetes runtimes. 1 minute per remaining slide. Okay, thanks, Miles. So Ubuntu is widely leveraged, widely used, as you know, as you might know. And so this partnership agreement really helps us bring these technologies together. So I'm going to have to fly here. So number one, Cloud OS, vastly higher levels of adoption versus every other distribution, essentially. And so there's a lot to gain from doing this. And if you want to know more about what we're doing with Canonical and some of the details of the announcement, please do look at the resources that are available publicly, but also will be available with this slide. So chiseled Ubuntu just means a hardened, pre-compliant, and very efficient Ubuntu or Linux distribution, right? It's built and distributed with precisely what you need, or the minimum of what you need, to ensure that you have the smallest attack surface, you have the tools you need to get started, and efficiency as far as consumption of underlying resources. Okay? Again, more to learn about that in a lot of the content we've put out there. There's been several blogs, announcements, white papers, and so on. I think white papers, not sure. These chiseled containers are shipped shipped and supported by Broadcom, by us, and they are applicable to anything that's being deployed, or can be applicable to anything that's being deployed onto VKS, right? And then we do provide the support for Ubuntu on the full VCF stack and certify that it functions and integrates, have certified that it functions and integrates with the whole thing. So flying along here, jumping into operations and performance. Now, this is something that I opened up with, I think I opened up with. Now, why VCF for Kubernetes? And this topic is probably the most important one to spend on that message. vSphere is world-class. vSphere has proven itself, right? The most business critical, biggest monster VM, needs and scalability, et cetera, have been running on vSphere for years, right? Decades. And so the idea of putting Kubernetes on vSphere is pretty much a no-brainer, right? And Kubernetes has been running on vSphere for a solid 8 to 9 years at this point in various forms. Now, running a Linux VM and Kubernetes in there, obviously that's been going on forever, but since Kubernetes was introduced. But specifically, why would I run my modernized applications in production on top of vSphere? Well, first of all, we have vSphere. It is the hardened, highest performing, most scalable underlying platform of any private cloud. It's going to give you that scalability and that performance that you'd expect from a public cloud experience in your private cloud, right? We didn't have to do a whole lot of magic to get there. This is what the platform has always done. So it was primed for running modernized applications at scale, right? The security and compliance, if you look at some of the surveys that are available publicly and some that we've done, compliance is probably number one as far as concerns for modernizing applications or running apps in Kubernetes. Now, put that in a public cloud, security is even higher. So again, leveraging the proven platform in vSphere. And the performance aspects of all of this is in the performance section. With Kubernetes workloads, we're still taking advantage of all the performance characteristics of vSphere. That means access to NUMA nodes. That means the availability that comes with vSphere. That means vMotioning. That means planned maintenance. All of these different things we can do with vSphere that we've enjoyed with our VMs and now extend to Kubernetes. And it is why, for example, OpenShift on vSphere is one of the largest implementations or most prominent implementations of OpenShift because they're taking advantage of everything vSphere has. So what we've done is just made it native to the platform, right? Makes a lot of sense. It gives you that direct access and performance and scale and so on. Networking. Now, performance is going to span all of those things, right? All the entire underlying platform. So the compute, the network, the storage. From a networking perspective, performance is in the uptime. Performance is in the time to availability, right? Performance is in the ability to run under my network traffic and flows in ways that provide the greatest amount of efficiency. Again, replicating what we do in the public cloud. If I can have my Kubernetes infrastructure and clusters and workloads communicate with my traditional VMs, which, as I mentioned earlier, is a very common thing that I'm going to need to support. Doing that all in a single platform with a single overlay network with NSX and all the benefits and support and performance that NSX provides, it just makes sense. So the network will automatically scale with the workload, and the network also extends all the way deep into the guts of each container, each pod, each cluster, and so on, right? So scalability is performance. If I scale but can't keep up, that's going to be a huge performance hit. And so we do need to tie all of these things into the performance conversation. Now, lastly, take advantage from a performance perspective. Taking advantage of vSAN is going to be another way to add power and performance into my Kubernetes clusters or Kubernetes-based workloads, containers, and so on. With the introduction and the wide adoption of vSAN ESA, I'm now taking advantage of the low latency, the IOPS, the huge performance benefits of vSAN being integrated directly into the platform that's running these Kubernetes clusters, interacting with storage through a declarative API, and having all of that storage and all that goodness available to my workloads. Okay. There's also other aspects. There's the security of of my encryption at rest, encryption in flight. There's the dedupe, there's the lower storage costs. So everything vSAN provides. But to stick to this particular theme, full speed, low latency, available to all workloads, Kubernetes just being one of those workloads. And we've also introduced different views, dashboards, and integration points across the operations stack with VCF operations, showing or allowing you to automatically discover your Kubernetes workloads and clusters. What we're showing here is Kubernetes clusters specifically. Now, this is on the ops side, right? And we could map out your Kubernetes clusters and discover all the different aspects of it. Specifically digging in or drilling into VKS, again, with VCF, is all integrated out of the box. I can now look at every aspect of the service I'm running. So if I'm more concerned about the dial tone itself, right, I want to be able to drill as deep into those dashboards as possible. With VKS logs and integration of logs, what used to be called Log Insight, into VCF operations, now extending into Kubernetes. So I can do a lot of deeper analysis and log tracing coming from an operations perspective. All I'm showing here is that this all extends into Kubernetes, leveraging your native Kubernetes constructs, terminologies, and so on. And last but not least, with network flows, again, end-to-end network flow visibility and network operations for my Kubernetes workloads, even end-to-end hybrid workloads, and so on. So all of this helps me not just tune for performance, but prove it, right? And ensure that I'm on the right track to continue delivering the goods to my Kubernetes infrastructure. Now, if you're on this call, you're probably in a situation where you're either trying to position VCF as an existing platform and trying to get the GitOps or DevOps or your development teams or PEs to understand that it is a viable platform. Please do have those conversations. Now, if you are a developer, app owner, or platform engineer, there's a lot of content that we can go and spend a little more time diving a lot deeper into. But chances are you're somewhere in between, right? So for cloud admins, what do we care about the most here? If your role is to deliver cloud services to your enterprise, you're worried about having a common platform, right? Having it secure, having a platform for all types of workloads that can benefit from common set of policies and controls, right? You don't want to have separate run books for every single platform and every single workload type. It's just nonsense these days. We shouldn't be having those conversations at all, right? Most importantly, on a Kubernetes side, getting support, enterprise level support for not just the Kubernetes distros that are happening now, right? It's where I'm coming from. I need support, and I need to not be left behind, as most providers will do. So N-2, and then we also just introduced that 24-month support. And then take advantage of, or understand that you're taking advantage of the benefits of a secure, very compliant underlying platform and all the tools to help you report the compliance and security and so on. Okay, and then for the platform engineers, you want CNCF certified. That is a big obvious duh at this point, right? You want the support. You need the tools that integrate. I didn't spend a whole lot of time. I just quickly skipped a slide, but ecosystem integration is a huge part of our strategy. There is absolutely no world where we live and we think VMware is going to provide all the tools you need to do this. Obviously, our first goal is to make sure we integrate with all the tools that are also supportive of a conformant Kubernetes cluster. Again, if it's conformant, that means it should work with these tools out of the box, which is why we're here, right? Multi-cluster lifecycle, drive efficiency into how I operate my environment. I need to be able to back things up, build policies to ensure that things aren't happening. without my discretion, and then have that common single declarative API across the entire environment. Now, I do think I went a little bit over, or was I right on time? Oh, maybe a minute over. But with that, I really do appreciate everybody's time, and sorry for some of the rambling I did there. But yeah, these recordings will be available. And to answer that question, if there's any last minute questions at this point, please do. I'm not sure if the deck itself, I'm just answering a question here. I'm not sure if the deck itself is going to be made available, but I'll check on that. Please do ask any questions. Thanks for all the questions that have been placed. I'm seeing more. Okay. Now, do take this as a kind of an introduction into a conformant Kubernetes, that is VKS. We've put a ton of material and content out there, so stay close, especially to Audrey and Miles and myself, and it's a pretty large team that we're just continually putting new content, demos, and blogs and white papers and all that stuff, in all types of different subtopics. So do look for that. Thanks again. Enjoy the rest of the day and the event, and we'll see you next time.